Hello everyone, I'm pleased to welcome you to the Quality Control and Quality Assurance Training course. Your role is invaluable to ensuring air traffic safety at your facility, and I'm proud to say that with your help, more than 99.9% of all operations are conducted as expected. However, we still need to close the remaining gap as much as possible. We're implementing a national safety initiative that reaffirms our commitment to quality control. This directly affects your contribution to the safety of our national airspace system. With our proactive safety approach, we're in a much better position to see where safety gaps exist. Our safety management system is complex but can easily be boiled down to 3 functions: collect, find, and fix. We're collecting a wealth of safety data from voluntary safety reporting programs like ATSAP and TSAP. And with your efforts to observe local operations and use the tools available in CEDAR, you help us find and identify hazards, directly contributing to the risk analysis process. Through your efforts, we're able to fix these gaps in safety by developing and implementing effective corrective actions. And then we monitor these actions through the Quality Control Program. The idea is to locally assess and understand how these corrective actions are working to ensure we're implementing them correctly. These basic fundamentals of aviation safety management, collect, find, and fix, were developed more than 100 years ago, even before the first flight lifted off in Kitty Hawk, North Carolina. Let's take a step back in time and see if we can identify how the early efforts of the Wright Brothers parallel with what our local safety teams do and what you do today.
We all know about the Wright brothers, Orville and Wilbur, and how they became the most successful of all aviation pioneers with their first flight in 1903. But the most ingenious part of the story is what came before. In 1892, Orville and Wilbur made an impactful career change from newspapers to bicycles. After their success in the bicycle repair business, they began manufacturing their own bicycle brand in 1896. So what did 2 bicycle men in Ohio know about aviation or creating a safety management system? At the turn of the century, in 1899, the idea of flight was really taking off, no pun intended. During this influential time, Orville and Wilbur's bicycle endeavors funded their growing interest in flight. In 1900, they made their move to the Outer Banks of North Carolina to begin manned gliding tests. Kill Devil Hills had frequent winds and a soft, sandy landing surface. They made that their camp for the next 3 years. But the Wright brothers weren't the first aviation pioneers, and they weren't just drawing from their own knowledge and data. At that time, gliders were being tested all over the world, including Germany by Otto Lowenthal and the Smithsonian Institution by Samuel Langley. The brothers requested information and publications about aeronautics from the Smithsonian. Even their decision to find a camp on the mid-Atlantic coast was a suggestion by one of their aviation friends. So today we know the benefit of aggregating data. The more data we have, the more accurate we can be. While Langley was experimenting with powered gliders, the Wright brothers favored Lowenthal's strategy, which was to master the art of control while gliding to later attempt controlled motor-driven flight. Lowenthal's death from his glider's plunge and then the death of British aeronaut Percy Pilcher reinforced the Wright brothers' process that pilot control was the key to safe and successful flight. Eventually, the Wright brothers discovered wing warping. Prior to their discovery, there were only 2 axes for control, yaw and pitch. Now with wing warping, which creates roll, they could effectively steer and maintain equilibrium. Controlled flight was finally on the horizon, and their invention of 3-axis control is still the standard on all fixed-wing aircraft today. After gaining glider control, the Wright brothers were ready to tackle the problem of lift. Until resolved, they would not be able to design good wings. They decided to use Lowenthal's published data even though they didn't necessarily agree with his approach. The Wrights began initial testing of lift by building a mechanical representation of Lowenthal's simple algebraic equations that they had previously used to calculate the performance of their gliders. Then they took a bicycle wheel and mounted it horizontally so it was free to spin in front of the handlebars. At a particular point on the wheel's rim, they affixed a flat plate, and at another point on the rim, they attached a curved plate approximating a cambered airfoil. Both metal plates were at the same size and mounted vertically. The size and position of these two surfaces represented the equation they were using to calculate performance. These calculations revealed that if they rode their bicycle with the tiny wing angled at 5 degrees to the wind coming at it, the wheel should remain still, because the pressure on the flat plate should equal the force on the curved wing. Once the Wrights tested Lowenthal's data in this innovative and tangible way, they discovered that in order to balance the wheel, they had to set the airfoil wing at more than 3 times the angle than Lowenthal's calculations, which was a major difference. This was simply confirmation of what they had discovered with the gliders. Their simple experiment led the brothers to initial tests in a homemade wind tunnel, which further illustrated that Lowenthal was wrong. They responded by building a larger wind tunnel, 16 inches across, with which they launched a comprehensive study of the lift and drag of wings. They tested more than 48 wing shapes and eventually found one that would work. The Wrights collected more accurate data, enabling them to design and build wings and propellers that were more efficient. All the while, the Wrights kept very detailed documentation of every step of their process. This research gave them solid foundation for designing the wings of their 1902 glider. More lift and less drag by careful choice of wing cross-section and by making wings long and narrow.